Alright, we're going to solve some more rational equations today. So first off, since I already have two rational expressions with the same denominator, I'm going to subtract 15 over x over to end up with negative 8 over x. That's easier than adding on the left and having to get a common denominator. Then, since I'm dividing by my variable, I want to undo that by multiplying both sides by x over 1, which will give me 4x over 5 equals negative 8. Now I could multiply by 5/4, or I could multiply by 5 and then divide by 4. I'm actually going to do that this time. So if I multiply both sides by 5, I get 4x equals negative 40, and then divide by 4, you end up with x equals negative 10. Look at the denominators of your original equation and think about if I was to plug that back in, would it make me divide by 0? It does not, so you're good, and that's your solution. Same idea here. Since I already have two rational expressions with a common denominator, I'm going to subtract x over x minus 5 from both sides to get the ones that have the same denominator together. So if you do that subtraction, you're going to end up with x plus 3 over x minus 3 equals, and then on the right hand side, since they have a common denominator, you can put them together as a single fraction and then combine like terms on top, subtract x, and you end up with just 5 over x minus 5. Now here, I could start on the left, start on the right, doesn't really matter. I'm going to start on the left, multiply both sides by x minus 3 over 1 to get that to divide out to 1 and not be in the denominator. That'll leave me with x plus 3 equals 5 times x minus 3, or just 5x minus 15 if you go ahead and multiply, over x minus 5. Same story on the right. I need to undo the fact that I'm dividing by x minus 5, so I'm going to multiply both sides by x minus 5. So if you do that, it'll divide out to 1, and you'll have just 5x minus 15 on the right. On the left, if you distribute everything, you're going to end up with what I've got jotted down there. You can combine your 3x minus 5x and make it into negative 2x. Now it's quadratic. I've got x squared and x's, so I want 0 on one side. I'm going to add 15, which actually will add to 0 on both sides. If I subtract 5x, I'll end up with negative 7x. So x squared minus 7x equals 0. You can factor out a common factor of x and then set each factor equal to 0, which will give you solutions of x equals 7 and x equals 0. Check to make sure those aren't extraneous. They're not, because only 3 and 5 would make you divide by 0. 7 and 0 should be fine. All right, nothing here has a common denominator, so I'm going to go ahead and subtract the two rational expressions on the left, which means I need to factor and get a common denominator. So if I look at that denominator, I can factor it using 2x plus 1x, because those multiply to 2 and add up to 3. And then I can factor out an x, which leaves me with x plus 2, and then just factor out a 1. So it factors into x plus 2 times x plus 1. Now I'm going to go ahead and work on getting that common denominator on the left. So I'm going to need to multiply my first rational expression by x plus 2 over x plus 2 to get a common denominator. And actually, when I rewrote the right-hand side of this equation, I went ahead and factored that denominator into x times x plus 1 because that's going to be needed for later. So if I do my multiplication, I'll take my 6 times my x plus 2, and then it'll all have the same denominator of x plus 1 over x plus 2, so I can write it as a single fraction. If I actually work on simplifying the top of that fraction, I'll have to multiply before I subtract, so let me distribute and multiply my 6, and then I can combine some like terms and subtract 12 minus 5 and get 7. Now, I have a whole bunch of variables in my denominator. I need to get them out, so I'm going to multiply by x plus 1 and x plus 2 on both sides of my equation. That'll undo my division, and they'll divide out to 1. So I'm going to have 6x plus 7 equals, if you look on the right-hand side, you actually really don't want to multiply everything together and distribute it, because you have a common factor of x plus 1 that you could go ahead and divide out. So let's go ahead and divide it out. That's super important to make your life easier. If you have any common factors that can be divided out, go ahead and divide them. Then I'm still going to need to multiply both sides by x to get it out of the denominator. That'll give me 6x squared plus 7x equals, if I go ahead and distribute, 3x plus 6. Another quadratic, so let's get 0 on one side. We can subtract 3x and subtract 6 and end up with 6x squared plus 4x minus 6 equals 0. Now, if I'm thinking about factoring, I would need some things that multiply to 6 times negative 6, negative 36, and add up to 4. If I list all of the things that multiply to negative 36 or 36, I'm not going to be able to come up with any combination that'll add up to 4. So quadratic formula it is. So quick reminder, there's your quadratic formula. Your A is going to be 6, B is going to be 4, and C is going to be negative 6 when I plug them in. So if I plug everything in there, remember you want to go ahead and work on simplifying inside your radical first because it's a grouping symbol. So if I do 4 squared minus 4 times 6 times negative 6, that's going to give me 16. Since I have negative times negative, will end up being plus 144, which will give me 160 inside of my radical. Now I'm going to want to break down that square root 160, so let's make a little factor tree. I'm going to go 16 and 10, and then actually I'm just going to stop with my 16 at 2 4s because those already have a pair of matching factors. So I can bring out my 4 by taking my square root of 16, leaving my 10 inside. And then if you look at my result, all of those are divisible by 4, so I'm going to divide everything by 4. And you'll end up with that as your solution. If you think about plugging it back into your original, it's not going to make your denominators equal to 0, only negative 1, negative 2, and 0 would do that.